Okay, let's get started with talking about thinking through an SOL question. So when we're looking at these SOL questions, this is something we're going to be doing at the end of the year when we take the SOL test. And, as I've talked to you all before, the goal of this class is not to pass an SOL. The goal of this class is to learn earth science, is to be competent and knowledgeable about earth science. And if we meet that goal, then we'll pass the SOL without difficulty. All right, so let's look at this first question. So in this first question, it's asking about point Y. So it says the fossil at point X has been dated to be 65 million years old. So when we look at that, that's important. 65 million years old. It's not as important as the next thing we're going to highlight, but it's important. So it's then asking, what can relative dating indicate about the fossil at point Y? So even if we don't remember exactly what relative dating means, hopefully we at least can remember that relative dating sounds like your relative. So it sounds like something that's similar or related. Just like you are similar to your brother, your cousin, your sister, someone else that you're related to, relative dating means similar. So when we look at these answers, there's only one answer that has similar in the name or in the question, in the answer. So we can't really tell the age when it died. We can't really tell that about any fossil. It's hard to tell whether it was 8 years old or 9 years old or 15 years old when it died. So we'll go ahead and mark that one out. It's also hard for us to tell the type of environment that the organism lived in. While yes, both of these are in the same like brick pattern kind of, sediment, that doesn't necessarily tell us the environment, like in terms of what the climate was like or, the plant life. So we'll go ahead and mark that out. So then letter C, the distortion of the organism by the fault. So if we think back to our principles of superposition and our laws of intrusion, this fault right here, this line, is where it was broken and this piece dropped down. But looking at point X is not going to tell us if point Y, if the little snail at point Y has been smushed or otherwise distorted in some way. So we're left with the choice that we had considered before, which is point D, or letter D, the similar time period in which the organism lived. So let's look at this next question. The remains of ancient life. So if we look at the remains of ancient life, we call those fossils. So fossils, if we remember, are preserved in a variety of ways. But this particular question has a couple of keywords right here, most often. So this particular question is asking about how are fossils most often created? So when we look at these answers, there's not ice covering the entire world, so we know it can't be freezing. And when we talk about drying out, that's mummies. So most fossils are not mummified. Now, if we think about how we have to find most fossils, we find most fossils by digging in the ground. And if they're entrapped in tar, we can't really dig them out because tar, is the same kind of stuff they make asphalt out of. So it would be like digging through liquid road. So that leaves us with letter B as our best choice, that they are buried in sediment. All right, so these next two questions are the infamous technology enhanced interactive questions. So what that means is that you're going to be asked to take pieces and drag and drop them into the right place. So, this is just a picture. I'm not going to be able to drag and drop it, so we're just going to draw with arrows. And the tricky thing about these questions is they're all or nothing. So if you have one box out of place, then the whole question is wrong. So when a river flows into a lake, the velocity of the water decreases. So they're kind of giving you what's happening here. You don't really have to know that. You have to know what velocity means. And velocity means speed. And even if you didn't know that velocity means speed, we could use some of the things in the sentence to figure that out. That as a river flows into the lake, something is going to decrease, and the only thing that's really there to decrease is the flow. So as the flow slows down, the larger sediments are going to drop out first because they're heavier. So that means this large gravel right here will go in number 1. Now let's say I can't remember whether sand or clay is bigger. I can look at this handy picture and see that these pieces of sand are bigger than these pieces of clay. So using the same kind of logic that, the largest thing is going to fall out first, the medium-sized one will fall out next, and then the smallest one will fall out last. And so that's how we would think through a question like this. All right, now this last one is a little bit trickier because if you notice, there are 4 spaces here, but 5 boxes. So let's see if we can narrow some of these down. So organic, we've talked about organic a lot. It's one of those big science words. Organic means living. So anything that we describe as organic either is living or was once living. And so when we look at this list here of processes, only one thing on the list has something that is or was living. So the sinking of plankton is the only thing that really goes with organic. So we're going to put that right there. All right, so let's look at these other ones here. So we've got compression of the crust. Now compression sounds a lot like one of the words that we used to describe metamorphic rocks. Compression sounds an awful lot like pressure. And that is one of the ways that we form metamorphic rocks. So we're going to put metamorphic right here. All right, so let's look at another one. Now let's say we remember that granite is an igneous rock. And we also remember that igneous rocks can either form underground or above ground from cooling magma and lava. And that when they cool underground, that means they're intrusive, that they cooled inside the earth. So we're going to put this one there. All right, now this last one is evaporation of the ocean. So we remembered that evaporation has to do with, or that igneous rocks come from magma and lava. So we know it can't be extrusive igneous because that means it's magma or lava that's cooled on top of the earth. So the only one left for us is this chemical sedimentary. So these extrusive igneous is just an extra one that we're not going to use. And that's okay, because there are going to be some of these questions where you'll have extra boxes or extra things that you can't put into a box. So we'll keep practicing this. This is the first of many. So thank you.